Hey there, class. Today we're going to start the first day on 11.4. We're going to talk about area of irregular polygons and composite figures. On the next one, 11.4, day 2, we're talking about regular polygons. So today we're going to estimate the area of irregular polygons, and we're going to talk about why it's estimating when we actually get into it. And we're going to find the areas of composite figures. Remember the word composite? Think about what that means. Composite, it's composed of multiple figures. All right, so first off, let's look at a map of the United States. Now notice some of the states are nice and square and some of them have irregular edges. Think about why are some of those having irregular edges? Specifically, we know here in Minnesota that this edge here, and it goes all the way down, is based on the Mississippi River. That's what created a border here. So some states were built based on those borders, those natural borders, rivers, lakes, such as the Great Lakes here, etc. So those are what determines the borders in the creations of those states. So think about, it wasn't as easy to find the area of the state of Minnesota compared to the state of Colorado. Colorado's pretty square, so you could almost find the base and the height and multiply them and get a pretty good estimate of the area. Well, with Minnesota, we weren't able to do that. Back in the days when it was settled based on a lot of farms. That's how many of the states began. And think about farms. Farms are going to be blocked off in acres. So if we wanted to find the area of something, we'd probably count how many full acres there are and how many partial acres there are. And so that's very similar to how we're going to actually find the area of our irregular regions. So here's what we have for our area of irregular regions. They are going to be, we're first going to count the number of full squares. All of our irregular regions are going to be on graph paper. We're going to count the number of partial squares and divide by 2. We're going to add the numbers from part 1 and part 2, and then we're going to multiply the area of one square. Now the reason why we're considering this an estimation is because if we look at this area, specifically let's look at this square here. Now, if you look up in the corner, it looks like it kind of cuts off that square there. So one day you might count that as a full square, and another day you might count that as a partial square, because if we look here, this square has just a little bit of lake there, and maybe that counteracts that. So maybe we'd count those both as partial squares. That's why this is considered estimation. So you and your neighbor probably shouldn't get the exact same every time you do this. So I like to have two different representations for my full squares and my partial squares. So first one, we're going to count full squares. So I'm going to go through and I like to X off anything that I consider a full square. So go ahead and do that on your paper, is cross off those full squares with X's, or if you choose something different, that's great. And once you finish that, then let's go ahead and, oops, I don't want to count that as a full square. And then let's go ahead and count how many you have. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27. So I have 27 full squares. Now I'm going to go through and I'm going to pick a different color. If you have two colors, that's great. And I'm going to also do a different symbol to represent our partial squares. So I'm going to do dots. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26. So I have 26 partial. But remember that we need to divide that by 2. And so dividing 26 by 2, I get 13. All right, let's go back to step 3 now. No, step 3 says add the numbers from part 1 and part 2 together. So I'm going to add my full plus half my partials. And if we add those together, I end up with 40. Now, today I end up with 40, but when I made my answer key a few days ago, I ended up with 28 full and 24 partial. So really, it even depends on the day for each person on what they're going to end up with. All right, and the last step, number 4, multiply by the area of 1 square area. All right, so I'm going to take my 40, and I'm going to times it by the area of 1 square. Here it says each square is 2 miles in length. So that's saying this is 2 and this is 2. So we're going to multiply to find area, and so that means my area for 1 square is 4. So I'm going to take 4 times 40, and my estimate is going to be 160 miles squared. All right, so we would follow the same exact rules and steps for problem 2 to find the area of the lake below. The only thing that I'm going to ask that we do together as we talk about is 0.25 miles in length. So this is 0.25 and this is 0.25. Again, we are multiplying to find the area. So if we multiply those, the area of 1 square, I'm going to have you guys, it's going to be 0.0625. Otherwise, I want you guys to do that all on your own. So 1, come up with how many full you get. 2, come up with your partial. Then divide that by 2. And then 3, don't forget you're going to add parts 1 and parts 2. And 4, you're going to take that answer and you're going to times it by 0.0625. All right, so that's about irregular figures. Now let's talk about composite figures. A composite figure is something that has very straight lines as opposed to the irregular. A composite figure is a figure that can be separated into regions that are basic geometric shapes. So if we look at the picture that I have below, you can see that it's broken down into a triangle here, another triangle here. We have a rectangle, not quite sure yet if it's a square, and then we have some partial circles. And so when we do composite figures, we actually find the area of each shape and then we add them together. So let's look at number 1. Find the area of the figure below. And it's already broken up into shapes, and I'm already telling you what I want you to find. So the area of the semicircle. So we're starting off here. All right. Now remember the area formula for a circle is pi r squared, but we are dealing with a semicircle, so we divide that by 2. And they give us our radius. So go ahead into your calculator, type out pi 4 squared divided by 2. So I'll give you guys a moment to do that. Pause if you need to. When you do that, if we round to 1 decimal place, we end up with 25.1 feet squared. All right, our next portion is going to be doing this triangle right here. And with this triangle, we have 2 of the sides, and we should find the third one. Now, looking at it, we could maybe assume that this side right here is another radius, but just to be on the safe side, let's just do Pythagorean theorem. And double check and see what we end up with. Our hypotenuse is the 5.7, so let's do x squared plus 5, equals 5.7 squared. Go ahead and try that on your calculator and find out what x is. So on my calculator, I end up with 4.06, and so we can roughly say that that's 4. And assume that that's going to be a radius. Let's just go with 4 for that. We could use 4.1. It's going to give us a close answer, 2. So if we do that, area of a triangle is base times height, divide by 2. So we're going to take 4 times 4 and divide by 2. And if we do that, we get 8 feet squared for our triangle. Last one is the area of our rectangle here. And rectangle is very easy, just base times height. And so we're going to take 7 times 4, and we end up with 28 feet squared. If we add all of those, that's going to give us our total area. And so we end up with 61.1 feet squared. If you rounded this to 4.1, yours is going to be just a very slight amount different than ours, and that's going to be okay. So go ahead and look here, find the area of the figure below, and it's broken into a semicircle and our trapezoid. Now for our semicircle, we would need a radius, and we don't have one here, And so we need to find it. And I'm just going to help you guys get this one started. This radius also will, or I mean this diameter will also stand for our height in the trapezoid. And I can also drop down a height here with a right angle. And it's going to be using that triangle at the end there to come up with that height. Notice that between the two green lines, it's 22. And from green line here to here is 31. So use that in mind to help you find the height for this area of this figure, for this figure. All right, now let's talk about number 3. Number 3 is not broken down into portions for you, and I just want to talk about how we could do that. Now there's multiple ways we could do this, and we're all going to end up with the same way. So I could break off here and make a rectangle on the bottom, and either A, have a trapezoid on top, or I can also break it into a triangle there. Another route we could do would be to drop down here, and again we can have a rectangle and a trapezoid, or break that into a triangle. And the last way we could do this one is to actually add something outside of our figure and make this an entire square, or a rectangle, excuse me, and then subtract out that area. So lots of ways we could do this one, and let's do it this way and pop it out. So now I'm going to take my rectangle, which is base times height, so 12 times 15, and we get 180 for that, and we're going to minus out this triangle area here. So for this triangle, we need base and height. Well, I know from here to here is 5, and that this whole thing is going to be 12. So if we take 12 minus 5, we find this to have a height of 7. Now, here to here is 8, and that whole side is 15. So if we go ahead and take 15 minus 8, we find this is 7. So for that red triangle there, base times height, and divide by 2. So 7 times 7 we know is 49. Divide by 2 gives us 24.5. Now if we go ahead and subtract our 180 minus our 24.5, we end up with 155.5 inches squared. Now I got the exact same answer, and I did this a previous way when I broke it into a rectangle and another rectangle and a triangle. So multiple ways, and you're going to end up with the same answer. For the last problem here, it says find the area of the shaded region below. So we're going to do the same type of concept for this one. Find the area of the whole big rectangle, and then find the area of the small one, and subtract them. All right, so guys, finish those problems up, specifically number 2 on the front, 2 on the back, and 4 on the back. And we'll talk about those tomorrow. See you guys.